So first of all, we're going to use the experiments to induce rules. So going from experiment to generalization. So I've labeled R1, R2, 3 there, just like the diagram in the corner. And I'm going to take measurements first with the ammeter and then with the voltometer and see what we can find out. So first of all, I'm taking the current reading at the very start. And so that is the current going in. And you'll see that that's 0.27 amps, and so that will also be the same as the current going out, which is Kirchhoff's rule. It's also in series, so current always stays the same in series because as the water flowing in has to be the same as the water flowing out. Now this time I'm taking the current, splitting it just on that R3 branch, and you can see it's 0.15, so it is less. And then if you take the current reading on the R12 branch, which will be the same on either side of the R1 and R2 resistor, it's also 0.12, which exactly is split up as 0.27. All right, now I've jumped quickly to the voltometer now, and you can see the voltage for V1 and V2 are that add up to V2.8. So you can see that voltage splits. But when you take the voltage at R3, it's also at 3 volts. So the voltage does split up in the R1, R2 branch, but it is the same in the R3 as the total. So voltage splits in series, but stays the same in parallel. Moving on to the calculations now. So the first thing you're going to do is work out what can be done, and then you just work your way forward until everything's worked out, all the current voltages and resistances. So typically you'll always know what the voltage is. You'll be given the voltage on the battery, or maybe not. And typically you know what the resistances of the resistors are. So we've got bulbs here as resistors here, and we've got 215s and 20 just like in the experiment. And you'll see that numbers add up. If you want to drag back and compare the two, the numbers are the same with slight experimental errors. And so the easiest thing to do is resistors in series add up. And so R1, R2 there adds up to 30. What's a little more difficult is resistance in parallel. So 1 over R total equals 1 over all the individual ones. So we treat R1, R2 as a single resistor now. And so 1 over 30 plus 1 over 20 gives us the resistance there. So is 1 over R total equals 0.0833. Now don't forget that's 1 over R total. It's one of the biggest mistakes. So use your algebra or cross multiply or whatever to invert those both. And so the resistance of the total circuit is 12 ohms. Now because we now know the total resistance of the entire circuit, we know the voltage for the entire circuit. So we can work out the current for the total circuit. So that's the current going in and current going out. So V equals IR, so rearrange that and we have I equals V on R, so the 3 divided by 12 gives us 0.25 amps. Now we know the current going in and out are the same, but the current splits down the R12 branch and down the R3 branch. So we don't know what the current is down those branches. So the current down R3 will be, we do know the voltage going down R12 is 3 volts, and the voltage going down R3 branch is 3 volts because voltage stays the same in parallel. So you see here we need all the rules to be able to work out what we do and we don't know. So we can now work out the current down 1 and 3 because we know the voltage is the same and we know the resistances. So for I3, the total divided by R3 is 3 volts divided by 20. So there's 1.5 amps going down the R3 branch. And for I1, which will be the same as I2, which you can call I12 if you want, will be the voltage, which stays the same, and the total resistance, which is 15 plus 15, which is 30. So 3 divided by 30 is 0.1 amps. And so we know we've got that adds up as a double check. So the 0.25 splits up into 0.15 down R3 and 0.1 down the R12 branch. Okay, and so just lastly, the voltage drop. So the other rule was the voltage gets all completely used up. So you have voltage on R3 all used up in the one resistor, but in the R1, R2, the voltage is split up and must get all used up. And so voltage was IR, so you know the current now, you know the resistance. So each R1 and R2 resistor is taking 1.5 each. Now if those R1, R2s were different sizes, they would take different resistances and use up different voltages, which you'll see in the next video.